everyone! Today we're going to start section 4, which is about presenting scientific data. This is the last section of the first chapter, so let's go ahead and get started. In order for news to be useful, it must be reported in a clear, organized manner. Like the news, scientific data becomes meaningful only when they are organized and communicated. Communication can be in the form of any visual representation, such as a graph or a table. Over on the right-hand side over here, we have a graph. This is extremely important to know how to do in science because it helps visualize information that we are given. Hopefully you've done graphs before, either in junior high or middle school. So let's go ahead and go through what this graph is showing. This graph is showing driving distance versus time. Notice that it has a title. Titles are very important when it comes to graphing. There are also two axes that we plot data on. On the bottom, the horizontal axis is also called the x-axis, and this is plotting time, and the h means in hours. So for example, this is 10 hours, 20 hours, 30 hours, 40 hours. Over here on the other axis, the vertical one, this is called the y-axis. This is where we're plotting the distance, and notice that it has a unit. My unit is in kilometers. So 1,000 kilometers, 2,000 kilometers, 3,000 kilometers, etc. We also see a straight line through data points, and this just shows me the more time that I travel, the farther my distance is going to be. So how do scientists organize data? We've already kind of hit on that. They do this by using data tables and graphs, and we just looked at an example of a graph. So let's talk about data tables. Data tables. They're the simplest way to organize data is to present them in a table. This table relates two variables, a manipulated variable and the responding variable. So let's look at those words. Remember, we said a manipulated variable is going to be the independent one. This is the one that you are physically changing. The responding variable responds to the manipulated one. So this is going to be also called the dependent, is what you guys learned it as, the dependent variable. So here is our data table. Of course, like all tables, it has a title, average annual precipitation for U.S. cities, and there are two columns. The one on the left, this is your location. This is actually going to be your independent variable. This is what's changing, is where they're located. The dependent variable is going to be how much rain they get. Notice that the independent is listed first, followed by the dependent, and you will always see tables given this way. For example, in Chicago, it runs about 91 centimeters, whereas Arizona, it's pretty dry, so it only rains about 30.5 centimeters. Now let's go into talking about graphs and different types of graphs. First one we're going to talk about is a line graph. A line graph is useful for showing changes that occur in related variables. So in a line graph, the independent variable, remember also called the manipulated, is generally plotted on that horizontal axis or your x-axis. So remember when we had that graph up at the beginning, that is going to be the one that runs left to right. The dependent variable, also known as the responding, is plotted on your vertical axis or your y-axis. This is going to be the one that runs up and down. So let's talk about something known as slope. Slope is something that is usually hit in your algebra class or later on in junior high, and we like to look at slope to see how things are related. Sometimes data points are going to form a straight line, and the steepness, or also called slope of that straight line, is the ratio of the vertical change corresponding to the horizontal change. In other words, you guys probably learned that slope equals y2 minus y1 divided by x2 minus x1. Ratio, remember, means division. An easier way to look at slope is to think of rise divided by run. So how much did you go up and how much did you go over? So here we're going to show an example of slope. It says plotting the mass of water against the volume of water yields a straight line. Notice, again, our graph has a title. We have a label down here, shows my x value is going to be volume in centimeters cubed. My y is going to be mass given in grams. So when we do this, slope is rise over run. So we go up, if we're looking at this data point and this data point, we go up 1, 2, 3, 4, 5. So there's my 5 grams divided by my run. So run, you go over 1, 2, 3, 4, 5. So 5 divided by 5 gives me 1. My slope is a positive 1. With those, you might see different steepnesses. Sometimes the steepness goes up and sometimes the steepness goes down. These are things called direct proportion and indirect proportion, or inverse. A direct proportion is a relationship in which the ratio of the two variables is constant. For example, if we're going to look at the relationship between mass and volume of water, this is going to be considered a direct proportion. Here I have my volume to be 3 cubic centimeters and my mass to be 3 grams. If I increase to 6, notice that my mass also increases to 6 grams. And if I increase to 9 cubic centimeters, I'm going to increase to 9 grams. So another way to look at a direct relationship, so as one variable increases, so does the other. Or you could also look at it as one variable decreases, so does the other. So if you were to look back at this table, again, as volume increased, mass increased at the same time. What is an indirect proportion, or also known as an inverse proportion? You'll hear them go either way. An inverse proportion is the relationship in which the product of two variables is constant. So let's look at what an indirect proportion is. Here we have a graph, and we're going to notice that our flow rate, or gallons per minute, are going to be our independent variable, and our time in minutes is going to be our dependent variable. So notice that as we increase the flow of water coming out of a faucet, it's coming out quicker and quicker. The time it takes to fill a pan decreases. So here, if water's coming out of a faucet at 0.5 gallons per minute, it's going to take 2 minutes to fill the pot. If I turn the water pressure up higher to about 1 gallons per minute, it takes less time to fill a pot, only about 1 minute. And if I turn that faucet on high, 2 gallons per minute, it takes even less time to fill that pot. Think about filling a bathtub. The faster you have the water coming out, the quicker the bathtub's going to fill. This is considered inverse. So the way inverse, the easiest way to describe this, as one variable increases, the other decreases. Let's talk next about bar graphs. A bar graph is often used to compare measurements, amounts, or changes. So we're going to bring up this little table again, average annual precipitation, and we're going to put it into a bar graph. Again, just like a line graph, you have to have a title. You also have your independent variable down here on the x-axis, and your dependent variable with your unit, centimeters, on your y-axis. Notice here, this is called a bar graph because you're seeing bars, shaded in colored bars. What this means is here's Buffalo, and it's going to be shaded in to 98. So notice that it goes up to 50 and almost touches 100, but not perfect because it's 98. Same thing with Chicago. Chicago's 91, so it gets shaded up to 91. This allows us to give a visual representation and easily see that Tallahassee gets the most rain, whereas San Diego gets the least amount of rain. So it's very easy to see that. One thing about the bar graph that I also want to point out that I haven't pointed out yet is notice that my increments on the side go up by the same amount. So I go 51, 152. And the last one to talk about is a circle graph. So if you think about a pie cut into pieces, you have a mental image of what a circle graph looks like. A circle graph shows how part of a share of something relates to the whole. So if we're looking at the whole picture and we want to just zoom on a tiny part. For example, just like any graph, this one has a title to know what we're looking at. We're looking at the composition of the Earth's crust. So as a whole, what is the Earth's crust made up of? And then we can focus on the individual parts, hence a pie graph. For example, oxygen makes up 46.6% of Earth's crust, whereas silicon makes up 27.7%, aluminum makes up about 8.1%, iron about 5%, and from there it gets smaller and smaller. One thing I'm going to point out about a circle graph is notice that with a circle graph, the number corresponds to how much of the pie that is taken up. For example, 46.6 is about 50%, which is half of a pie. Notice almost half of this is going to be shaded red for oxygen then. 1.5% is not a very big piece of a pie, so notice that it is a very small sliver. Now that we've talked about how we can visualize information, let's talk about how do we communicate the data once we put it into either a graph or a table. The way they do this is scientists can communicate by writing in scientific journals or speaking at conferences. Here's an example of a scientist communicating their data at something known as a science fair. Scientists can also exchange through conversations, emails, websites, or again, like the scientists here at science fairs. I actually did research in college where we flew to California and I presented at a big conference to a bunch of people. Now we're going to talk about peer review. What is peer review? Well, peer review is a process in which scientists examine other scientists' work. You have done probably peer review anytime you look at someone else's work. For example, in English, sometimes you'll be asked to read someone else's paper. When you proofread that and you give them suggestions back, you ask questions about their work, you give criticism, constructive criticism, or you give comments based back on their work and how well they're doing, this is called peer review. For example, they might say, hey, this idea isn't flowing, maybe try this. Scientists do the same thing. They send in their work, and peers that are their same level as them, that are studying the same field of science of them, is going to look at their work and give them suggestions or comments. Okay. So now that we've gone through this, let's look at to make sure we're understanding what we've learned. If for some reason you don't understand part of this question, I would go back through the video and see if you can find what the answer should be to ensure that you're getting these right. If you're struggling, I would actually rewatch this video. So number 1, which type of graph is most useful for showing how parts of something relates to the whole? A, bar, B, circle, C, column, or D, line? If you said circle, you are correct. The key word to look for there is how something relates to a whole. So the whole pie, we're looking at a small part of it. Number 2, how does a line graph generally show the relationship between the manipulated and the responding? A, the manipulated variable is plotted on the x-axis and the responding plotted on the y. B, the responding plotted on the x and manipulated plotted on the y. C, the manipulated variable is plotted on the graph and the responding is shown by the slope. Or D, the responding is plotted on the graph and the manipulated is shown by the slope. So let's just go back over this. Manipulated is going to be your independent, and your responding is going to be your dependent. Now, slope has nothing to do with independent and dependent. It's just how they're related, so we don't care about those. And that leaves us with A or B. So remember, independent, this is the one that's on the bottom, and you're going to go left to right. So left to right is going to be your x-axis. Dependent is going to be the one that goes vertical up and down, and that's going to be your y-axis. So if you said letter A, you are correct. Number 3, how do scientists communicate the results of scientific investigations? A, by writing in scientific journals or speaking at a conference. B, using secret codes. C, only through email. And D, by writing in literary journals. If you said A, you are correct. Now, the reason it could not be C is it says only through emails. Remember that you can also speak at conferences, you can talk through phone calls, you can go to science fairs. So this is why this one's out, because of the word only. If you clicked D, you would be incorrect because literary is going to be things for English. We want scientific journals since it's science. And 4, why is peer review an important part of the scientific process? A, peer review makes sure that the correct researcher gets credit for discoveries. B, peer review helps identify errors or bias in research. C, peer review is a system used to report information to other scientists. Or D, peer review helps other scientists form theories about a discovery. If you said B, you are correct. So when you read over work, this is where you're going to ask questions and find things that are wrong and give feedback back of things that they can do better. If you do not know what bias means, it means that your opinion heavily leads to one side because of you already either know the person or you get money for having that opinion. For example, if I was there's an argument between a family member and somebody that I don't know, usually people are more biased to support their family member because they already know them. And that is the end of today's lesson. Let me know if you have any questions, and I can more than happy to help you. And I hope you guys have a great day.